The closer we move towards reality, the harder it becomes. In dynamic analysis, we deal with changes in the economic variables. So the problems become complex and we need to use advanced techniques to solve these complex problems. In this video, you will be introduced to such an advanced technique that will help you to measure continuous change. Consider a perfectly competitive market. If the buyers are willing to buy more, but the sellers do not have sufficient supply, there is a case of excess demand. If demand exceeds the supply, the price increases and the equilibrium changes. If the price continues to be at the increased level, suppliers will increase the supply and there may arise a case of excess supply or negative excess demand and the price decreases and the equilibrium changes again. There are a large number of other variables such as growth of population, epidemic growth of a disease, depletion of ozone layer, growth of financial market, and so on, that needs sophisticated technique for its analysis. For example, the rates of formation of oxygen and ozone can be measured with respect to time. Population growth is instantaneous and the rate of growth of population is measured with respect to time. In order to study the economic variables in a dynamic situation, the concept of differential equation may be used. Differential equation was historically known as infinitesimal calculus. If you recall, the concept of derivative is used to determine the rates of change of variables, and the process of finding the derivative is called differentiation. If you see an equation with a derivative, that equation is termed as a differential equation. Consider the usual function. The derivative is given by dy by dx or f dash x. If we have an equation of the form dy by dx is equal to f of x, this equation has a derivative and therefore it is called a differential equation. The difference with a simple equation is that instead of a dependent variable y, a differential equation has the derivative dy by dx. Some examples of differential equations in economics are discussed as follows. You must have heard about the Herod-Dahmer growth model. This model explains economy's growth rate in terms of levels of savings and productivity of capital. This is the Herod-Dahmer growth model. Y dot divided by Y is output growth rate, S is savings rate, C is marginal product of capital, delta is depreciation rate. Solow-Swan model explains long-run economic growth by considering capital accumulation, population growth, and technological progress. K is capital stock per unit of effective labor. Alpha is elasticity of output with respect to capital. The term SKT to the power alpha is actual investment per unit of effective labor. The term N plus G plus delta into KT is the break-even investment. Black-Scholes model is used for dynamics of a financial market containing derivative investment instruments. V is price of the option as a function of stock, price S and time T. R is risk-free interest rate and sigma is volatility of the stock. Malthusian growth model is a model of exponential growth regarded in the field of population ecology as the first principle of population dynamics. P is population size, R is population growth rate, and T is time. Differential equations, therefore, may be used to study the behavior of complex economic systems.